So tangent graphs, we have y equals a tangent b of x, and that's going to be your parent function again. What happens with tangents, you start looking at them in terms of the quadrantals like we did before. Let's see, that's 1, 0, 0, 1, negative 1, 0, 0, negative 1. What's that?
You should make him do a problem on the fit.
Yeah, right? Something he doesn't. When we've done this before, we've talked about how tangent stuff works. Tangent is no longer continuous. Tangent has asymptotes. Tangent is undefined where and where. All right, well, remember this. Tangent is what divided by what? Hence why I left that there. So tangent is y over x. So that means we have to figure out where is x equal to 0. X is equal to 0 at pi over 2, 3 pi over 2. Okay with that? Now, if you think about it, when you're at 0, your tangent value would be 0. Okay. Because you get your y value 0 divided by 1, which is 0. When you get to pi over 2, it's undefined. If I get to pi, it's 0 again. 3 pi over 2, it's undefined. And then I'm back here. So if you get to it, you only have 1 point and an asymptote. 1 point and an asymptote. But what happens at halfway between 90, or excuse me, pi over 2 and 0? What's halfway between pi over 2 and 0? Pi over 4. What's the tangent of pi over 4? It's 1. Tangent here is 1, which means the tangent here is 1. What's the tangent here? Negative 1. The tangent here is negative 1. So what happens with tangent graphs, it changes up a little bit different. Tangents, this a value still works as what we call, it's not technically an amplitude, it's, we're going to call it amplitude-ish, if you will. We'll look at it as a, have I ever used the term points of inflection with you guys before? Okay. It's where something changes, where something goes, it changes direction of that. So that's kind of what happens here at the A value. It's a point of inflection. This B value still helps us define the period. But with tangent, the period is no longer 2 pi. Because if I went around 2 pi, I'd have a couple of breaks. So tangent is just going to have a period of pi over the absolute value of B. Okay. Tangent's going to be as pi over absolute value of B. The A value can be negative. It just will change the direction of the graph, and I'll show you what that's going to look like here in a second. Okay. Now, what happens with tangents, I think the really, really easy thing to do, oh, I don't want to get too far ahead. You okay? Okay. What's really easy to do with tangent is that when we graph tangent, tangent's the only one that we graph like it was if you were searching for an angle to start with. Remember when we searched for an angle at tangent, we looked at it between pi over 2 to negative pi over 2? That's how you graph tangent. We graph it between pi over 2 and negative pi over 2 because we know that at negative pi over 2, it's an asymptote. And we also know that pi over 2 is also an asymptote. The distance between negative pi over 2 and pi over 2 is how far? Pi. Okay, it's a pi, so that gives you your period. Right. So we look at it between negative pi over 2 and pi over 2. What's halfway between pi over 2 and negative pi over 2? 0. Guess what happens when you have tangent at 0? It's 0. Okay. And now, when you have your, what's halfway between 0 and pi over 2? Pi over 4. And then here would be negative pi over 4. And what's your tangent value at pi over 2? 1. And what's it at negative pi over? Did I say pi over 2? I'm sorry, I meant pi over 4, excuse me. So what's the tangent at pi over 4? 1. And what's tangent at negative pi over 4? Negative 1. And you get tangent graphs. Okay. What's that? Oh, go ahead. You can have, plus you have like an aha moment of something. No, please, even if it's stupid, draw us. Yeah. There you go. So when you have tangent graphs, what happens here is that the A value in this case would be 1. My B value in this case is also 1. To that, we would just shift and move things around. Okay. Let me show you an example of what it would be with a parent function with a different A and B value before I throw in an H and a K. Okay. So let's say we have y equals, let's do negative 4 tangent of 2x. Worried. What's my A value? Negative 4. What's my B value? So if my B value is 2, that means my period will equal pi over the absolute value of B, so it's going to be pi over 2. Okay. Now, when we go to graph this, we still make a 0. I'm still going to put asymptotes in. And I know that the distance between my asymptotes is the period. So if it's pi over 2 between the two, what's half of that? Pi over 4. So that means on either side, your asymptotes will be at pi over 4. So what happens here is to be able, if you want to think of it as a shortcut, your asymptotes will be placed at half whatever the period is. So if your period's pi over 8, half of that would be pi over 16, that places your asymptotes. It's that quick. Okay. Because between the asymptotes has to include one full period. Just cut it in half. It's the easiest way to do it. What is the tangent at 0? 0. And now with this value of A being negative 4, that means all I have to do is mark off 4 spots, because the point of inflection still will occur at the A value. It just occurs at halfway between the asymptote and your 0 on either side. So what's half of a fourth? So I'll have negative 8 pi over 8 and then a positive pi over 8. And then I know I'll have, since my A value is negative, instead of going increasing from left to right, I am now decreasing from left to right. I just changed direction. What goes into an FFA competition? Is it like in Napoleon Dynamite where they're drinking milk and they like this milk, this cow got it? That sounds utterly ridiculous.
Give us more buns.
really set me up on that one. No, is that, I mean, you know what, have you seen Napoleon Dynamite? When he's like, this cow got into some onions. Or something. I love that movie. It's, the first time we should. It's one of those. All right, you can write this. This was another one to write down. What's so good about Napoleon Dynamite is that it's so clean humor. There's not even like a word that I would say in class in that. They don't say anything bad. They might be like, "Shut up." That's about as worst they ever get. So when the first time my wife and I saw that, we're like, this is kind of dumb. My brother's like, watch it one more time. Then we watched it again, and you start to get all those little jokes that are in there. And then, yeah, I can't wait to show my kids it. Give me some of your tots. Bow to your sensei. It's really good. Anyway, since we just went off on that tangent. Oh.
I'm guessing you've been waiting all year for that.
Hey, why are you giving me the? But you were like. Let's shift one. Shifting tangent does the exact same thing as what we did before. I will say that when we shift tangents, I was right up here too. When we shift tangents, we have y equals your a tangent b x minus h plus k, where your h and k just move things left and right. When you get going into this stuff, the asymptotes will still shift, but since they're vertical asymptotes will only move left and right. Because if you move a vertical asymptote up and down, isn't it still the same asymptote? That's how it works. When you write out asymptotes, vertical asymptotes are lines. And vertical lines are always x equals some number. So like we did yesterday when we listed out ordered pairs, with tangent, if you think about it, there's really only going to be 3 ordered pairs. And then there are going to be 2 asymptotes. So you'll write out 3 ordered pairs, your 2 asymptotes, and then we just shift them according from that. Okay. So let's look at an example. All right, we'll do this one, and let's put in a k.
Okay.
Yeah, that's like tangerine.
What?
Is it June?
Oh, it's tax season.
Already done mine. Again, first thing you want to do is list out your A, B, H's and K's. Did you guys catch that one yesterday? I forgot to ask you about this. Did you guys catch that first problem yesterday where you had the B value hiding in the parentheses? I think it was like 4x plus pi. So remember, you factor it out, so you get x plus pi over 4 is what it should have been. Okay. That's, in all honesty, that's about as crazy as a lot of this stuff gets, where you have to be careful with anything hiding in the B value. In this case here, what's our value of B? So we have an A value of -2, a B value of 1. Our H value is what? Negative. Good, you picked up on that. And then your K value is 3. One of the things I would suggest with tangent graphs is that if you have a negative A value, are you decreasing or are you increasing from left to right? Decrease. So Mike, just do this so you don't forget. All right, just so as soon as you know that you have a positive or negative A value, that way you know which way to plot your points, because it's so easy just to forget it. Okay. Cosines and sines, when they're negative, it's a little bit more difficult because you can substitute value through and you know that you start at your a value, whereas if the a value is negative, you knew you started at the bottom, worked your way up, and so on. Let's see here. So we have a period then will be equal to what? So your period is pi because it's just pi over 1. So now we go ahead and start the plot. Again, knowing that I'm going to have to move to the left, it might not be a bad idea to over-exaggerate extra space to your left as you're doing your drawings. Okay. Period is pi, which means my asymptotes to start will be at pi over 2. It's very good. So we have pi over 2 negative and pi over 2 positive. Let's see. My a value is, I have a 0 and 1, 2, 1, 2. Halfway between here is pi over 4 negative and pi over 4. So we have positive 2, 0, negative 2. Tangent graphs have a lot of dotted lines. It's just one of those deals, just how that works itself out. So we have our ordered pairs. We know we'll have to have an x minus, x minus pi over 4 and a y plus 3. So we have negative pi over 4 and 2, 0, 0, pi over 4 and negative 2. Asymptotes are at x equals, bless you, negative pi over 2 and x equals pi over 2. Yeah, that way you remember that way you don't forget to shift those as well. Okay. So you're still writing out 5 things. It just happens to be just 3 ordered pairs and 2 asymptotes. 3 ordered pairs, 2 asymptotes, and a shifted tangent function. On the 3rd Friday of April, Mr. Murphy gave to me.
No,
That was good. So, if I subtract pi over 4 from pi over 4, I get pi over 2. If I take 2 and I add 3, I get 5. This one will be at negative pi over 4 and 3. And this would be at 0 and 1. My new asymptotes, if I move to the left of pi over 2 by pi over 4, I'm basically adding a quarter to a half and I get 3/4. So I have negative 3/4 pi. And then if I move to the left of 1/2, I get 1/4. Were the fractions so terrible yesterday, or were you guys doing okay by just kind of working through the common denominators? Yeah, and I told you guys this yesterday. It's not like you're going to get denominators of like 7 and 4, just awful things. So what I would do is I automatically would go back and plot new asymptotes first. So I'm at pi over 4. And then I'm at 3 pi over 4, negative 3 pi over 4, excuse me. My new 0 spot would be at negative pi over 4 and 3. And then I'm at 0 and 1. And then pi over 2 and 5. So here's 3, 4, and 5. And I'm coming down. Oops. And this is going to happen with tangents. They're going to get all kinds of. That's the reason why I have you guys list out ordered pairs. Because graphs are going to look like crap. They will. And that's okay. Especially for pairs. Yes, thank you, thank you. That's supposed to be negative. Sorry, thank you. Yep. I plotted in the right spot. Yeah, Yeah. Did you guys see what I messed up there? I tried to put my negative at the negative pi over 2 and 5 for the ordered pair. But you notice how I plotted it in the right spot? So let's say you did that. Are you wrong? No, you plotted in the right spot. If you plotted it at pi over 2 and 5, you made this weird looking hook thingy, then you know you're screwed up. So, yeah. I mean, a lot of these things you can kind of fudge your way through without having to like really, really think too hard. It's kind of nice. That's it. Tangents are easy. I just hate trying to do all that in one day. I mean, with science and cosine. Before you guys start yelling at me, hey, this is 14.1 and 14.2, which means you might have to go back to, I don't know, 2 days earlier to look at those PDF files. I'm sorry.
Can you just fax it to me?
Stop.
You know, fax machines are stupid. You should be able to use the email stuff. That's
We
just me.
have one in